Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Doppler Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue from the previous lesson, that is finding derivatives of trigonometric inverse function. So this is example number 18. So please, I urge that if you have not watched the previous lessons, you can make it your duty to at least watch them so that you get on path with the problems that we've been solving from the past. So to solve this problem, several ways we can approach it. One way we could do it is to allow this portion to be our u, that is using the chain rule. Allow this to be our u, differentiate this expression, and find the y by the u, and then you multiply the two of them. That is, you multiply the derivative of the y by the u by the derivative of the u by the x. But if you have this problem to find its derivative, it's going to give you a tough time to to work with, a very tough time. So what we can do, we can aim at first simplifying this expression. So we can simplify that expression by rationalizing the denominator. So we can say, let's take out the angle. That is the root of 1 plus sine of x plus the root of 1 minus sine of x divided by the root of 1 plus sine of x minus the root of 1 minus sine of x. So this problem is similar to this problem. What I did in this problem was to just interchange the plus and minus. I send the plus down, I put the minus on top. So you can just practice that on your own. So we can rationalize the denominator. That is, we take the conjugate, because there are two terms here, this root and this root. There are two terms, so we take the conjugate of this expression. So the conjugate is like the opposite sign to the two terms. So the opposite sign to plus is minus, and the opposite sign to minus is also plus, right? So we can say the root of 1 plus sine of x. Now we are not dealing within the radical. And then we say plus the root of 1 minus sine of x. So we do the same thing down. 1 plus sine of x plus the root of 1 minus sine of x. So like we said in previous lesson, when you have the conjugate produces the difference of two squares. That is x squared minus y squared, which is equals x minus y times x plus y. So it gives you the difference of two squares. So it means that as long as you take the conjugate of an expression, just multiply the first term by itself twice, the second term by itself twice. That's all. That is, this expression times this, and then this times this, because the middle term will always cancel. So in the numerator now, we can multiply these two. This time this gives us, so these two are the same, so it just gave us the radicand, so it's 1 plus sine of x. And then this time this one, it gives us, so since the roots are the same, we can just say the square root of the radicands, the product of the radicands. So you have 1 plus sine of x times 1 minus sine of x. And then we have this time this as well, right? So it becomes plus the square root of 1 minus sine of x and 1 plus sine of x. And then the last one is just plus 1 minus sine of x. So the root will just go out. All divided by the first two terms, 1 plus sine of x, and the last two terms, minus 1. Now this minus must affect both of them. That is, minus times this 1 and minus times this. So it's minus and plus sine of x. So what do you observe? This cancels this. This also cancels this. Right? Now we have 1 plus 1 gives us 2. So this is 2. And we can work within here. So you clearly see that these two are the same. So whatever result we have from here is going to be the same. So we say 1 times this is 1. So let's just do it on the side, and then we just put the result down. So 1 times 1 is 1, and 1 times this is sine of x. So there's also conjugate of each other. There's conjugate. So you can also say 1 times 1 and sine of x times sine of x, because the middle term will always cancel. So we just say sine of x times sine of x is sine square x. But we know that 1 minus sine square x is equal to cos square x. So the square root of cos square x will just give us cos of x. So this whole thing is just plus cos of x. And the same thing right here, plus cos of x. So it's now going to be 2 cos of x divided by, now what is here, sine of x, and sine of x is 2 sine of x. So this now produces 2 and 2, we can factor 2 out. We will have 1 plus cos of x divided by 2 sine of x. So this 2 can cancel this 2. So our result is just 1 over sine of x plus cos of x all over sine of x. So 1 over sine is cosecant of x, plus cos over sine is cot of x. So you can decide to work with this as your angle of this expression, of this sine or tangent function, or you can decide to work with 1 plus cos of x all over sine of x. So I will be working with the first, the first one, instead of this, because I just want to work with expressions in sine and cosine. So you see how it helps us to reduce the angle of this tangent inverse function. So it's always good sometimes to first reduce the problem into some simple form before finding its derivative. So y now becomes tangent inverse of 1 plus cos of x divided by sine of x. So we can find a derivative. So y prime, remember, the derivative of tangent inverse is just equals to 1 over 1 plus x squared. If we were using a general form, u is just going to be u prime as well. So it's 1 over 1 plus u squared times the derivative of the angle, that is u prime. So now we have 1 over 1 plus u squared. So this is our u. So it's 1 plus cos of x over sine of x all squared. Then times the derivative of this particular angle. So we can use the quotient rule. That is, we hold the denominator, sine of x, and then we differentiate the numerator. The derivative of cos of x is just equals to minus sine of x. And then minus, we hold the numerator now, 1 plus cos of x, and differentiate the denominator, which is now plus cos of x, divided by this denominator, sine of x all squared. So we can simplify y prime equals 1 all over. So this expression can be raised to the power of 2, and the denominator as well can be raised to the power of 2. So sine square x times this 1 is just sine square x plus, then we can expand this 1 plus cos of x times 1 plus cos of x, all divided by sine square x. Now I'm not going to I'm not going to bring in an identity for this because I'm seeing sine square x here as well, so I can get rid of it. Times sine of x, and sine of x is sine square x. And then cos of x times 1, this is minus cos of x. Cos of x times cos of x is minus cos square x, divided by sine of x all squared. So this can cancel this one. So we are simplifying the problem further because we were told that the answer is just minus 1 over 2. So most times to find the derivative of trigonometric inverse function is not really the problem, but to further simplify the problem, you need to find the derivative of trigonometric function as well. It's also to simplify the problem by breaking in some trigonometric identities and and other stuff, So we have y prime equals. Now we can multiply these expressions. So this is 1 over sine square x. 1 times 1 is just 1. 1 times cos is just cos of x. And then 1 times cos again is cos of x. And what do we have? The last one is cos square x. What is here? Now what do we know? We know that cos square x plus sine square x is equals to positive 1. So this sine of x and this sine of x, both of them the signs are negative. We can factor it out. So you can decide to factor out minus 1, for instance. So we will just have cos of x. This is positive now, cos square x. So let me not touch the problem. Cos square x plus sine square x plus cos of x. So you see that the first two is just equals to 1 or over 1. So the first two terms is just 1. So we have y prime, and also here this first term and the last term is also 1. So we have 1. So it's negative 1 times, this is 1 plus cos of x divided by what is down here, this and this is 1. 1 also plus 1. This is 2 cos of x. So what is there? You have minus 1 plus cos of x divided by 1 plus 1 is 2 plus 2 cos of x. So we can factor out 2 in the denominator. So we just have minus 1 plus cos of x all over 2 is outside, 2 into itself 1 times, 2 into 2 1 times, so it's just 1 plus cos of x. So what do you observe? This cancel this one. So our final answer is just minus 1 over 2. So this is how we find the derivative of trigonometric inverse function. Thanks ever so much for watching. See you in our next lecture. Please don't forget to like, to subscribe, and to share with your colleagues or your friends, whatever the case might be. See you in our next lecture. Thank you.